Welcome to this AP review video of a specific AP unit. Let's dive right in and take a look. So today we're going to be reviewing the AP unit on writing classes. So this unit, as defined by the AP curriculum, will have the following definition. It's about the foundation of creating classes. Now, this has been covered by me in the past in my Computer Science 30S course for the basics of classes, and in my Computer Science 40S course in a unit called Advanced Classes. There'll be links in the video description below to those those content areas and various other resources involved with that. All right, let's get started. So how does the AP describe this, right? So it's about classes and how classes can model real-world entities in a computer program, how classes can combine both properties and methods or data and actions together. And we'll be going through a lot of that in this review video. Here is the specifics in the AP curriculum. So from a big ideas section, it deals with modularity, it deals with variables, it deals with the impact of computing, right? In terms of the topics, there is 10 specific subtopics here that we'll be going through in Unit 5, writing classes. In terms of weighting for the AP exam, this is between 5 and 7% of the exam content. All right, with topic 5.1, the anatomy of a class. So here you can see the specific sub-details of topic 5.1. You can go through this video and pause it and read it in detail. There's a lot of AP vocabulary there, but we're going to look at how I've reviewed this, the specifics of this content in courses in the past, right? So when we deal with classes, if we talk about the concept of how classes can relate to the concept like encapsulation, we're talking about the difference between public and private. The analogy I've drawn in the past when thinking about this content is you could use it like a building where there are private rooms and there are public rooms in the building itself. And you could even divide the building into two parts, right? One area for one thing and one area for another. Now let's connect that to coding, right? If we think of one area of the building as the properties area and one area as the methods area, then you could also tie in a worker in the building. A private worker has access to the private areas. A public person would not have access to the private areas, but a public person can leave the building. Whereas a private person, someone who works in the building, cannot leave. This analogy draws nicely with the modifier word public and private. So if you're talking about, for example, a property, a variable of this class, if it is made private, that variable can be accessed and modified within the class itself. However, if you're outside the class in another class, then you don't have access to that private property. Similarly with methods, a public method can be called within the class and it can be called outside the class by using something like an accessor dot operator. Okay, so this is an analogy that I use to draw the idea between public and private in the 30S computer science course. Relates to the concept of encapsulation, where you can encapsulate or lock something inside, which is what a private property would do, right? And so I drew analogies to like capsules in cold remedies that lock things inside. So the idea as a programmer is you set up public and private, and you set up the concept of encapsulation to best model the class you're designing. And you can see examples of this in the code that is part of that 30S course, where we have both private and public properties and private and public methods. By the way, a private method is sometimes called a utility or a helper method. In its 40S course, we go a step further. We talk about in Java, there is kind of a level in between private and public called protected. Protected allows the class itself and the subclasses of that class to access things that are designated with the modifier word protected. So in the case of properties, a class that is a subclass of a class can access a protected property. In the case of methods, they can call those protected methods as a child of the parent class. Okay, so that relates in the example we did, both in the 30 and the 40S course, to that concept in the AP curriculum. Now let's shift to topic 5.2, constructors. So constructors, for those who don't know, are methods. They're methods of a class. Here you can see the AP curriculum breaking down section 5.2 with its content. But let's look at how I covered the concept of a constructor method in the 30S computer science course. We had created a method called born, which set properties, and then later worded that born method to become what's called a constructor method. I also talk about how you as a student would have seen constructor methods before when you take a class and turn it into an object. In other words, when we instantiate the class. Even back for those who took my grade 10 computer science code course with code lines like this fun one, random random equals new random, I would point out that this was a constructor method being called. At the time, you don't know that. You just assume that's the line of code you write, okay? So let's talk about what constructor methods are. There are these special methods that have, one, the exact same name as the class, including, in the case of the name of the method, uses a capital letter, just like the class name uses a capital letter. But also, really importantly, constructor methods have no return type, not even the word void. That's how they become constructor methods. So in the example we did in the 30S course, we rewrite the born method to become a constructor method, right? So here you can see the person constructor method. Generally, constructor methods are used to set the properties to starting or default values. All right. Out how constructor methods are automatically invoked or called when you construct an object. That's why they're called constructor methods, or when you instantiate an object of that class. Now, the other thing I point out is that constructor methods can be overloaded. You can provide several constructor options to a class. So here you see an example of the person constructor method that does take a parameter. If you do that, then that parameter is usually passed along and assigned to one of the properties of the class. That can be a reason why you are passing a parameter through a constructor. A point that's going to be brought up in a little bit. The constructor method, when it's overloaded, you tend to think about what you're going to name your parameters so that you don't have a name conflict with one of your properties. So for example, if you have a property called age, if you have a parameter called age, those two things can be in conflict. So you can come up with sort of different names, or you can use the special keyword this in Java, and this is a reference, an explicit reference to a later instantiated object. So within the class itself, we use the keyword this to make reference to the class itself, so that we can say something like this.age, which references the property of the class, versus just the word age references the parameter. And we'll talk more about this as you'll see it comes up in the AP curriculum in a moment. So again, you can see examples of all this in the Computer Science 30S code. You can see various examples of us using it, and that's why this is a review. You can also see more advanced revision of this in the Computer Science 40S code. All right, shifting gears, AP topic 5.3, commenting, documentation with commenting. Strangely appears in this specific section on writing classes, but here you can see the subsections of the AP curriculum about commenting. And there's lots of different examples of commenting. It starts in the 30S course. It's almost one of the first things I teach in the 30S. And yes, I teach commenting in the 20S computer science course, early on in that course as well. All right, now let's shift our gears to a specific type of method known as the accessor method. This is AP topic 5.4. So here you can see the subpoints of the AP curriculum. Feel free to read those, okay? You want to have a grasp of how it specifically lays it out and the vocabulary it uses. But specifically, the terminology accessor method is something I cover in the computer science 40S course. In the 40S course, I introduced the idea of naming a specific method an accessor, otherwise known as a get or getter method, right? The setters and getters for accessors and mutators is often common terminology in computer science. But as part of the AP curriculum, it uses the word accessor method, which I also teach in that 40S course. So it's a method that often starts with the word get, and then the name gets more specific after that. So you can also see that in that 40S example, where those methods, the get methods, are called, along with the set methods, which we're going to cover in a minute in this AP review. Okay, so an accessor method essentially gives you access to a property that is usually a private encapsulated property. Okay, so you can see that in that 40S content example. Very much related to this, AP topic 5.5, the mutator method, I also review at the same time in the 40S content. And you can see this, and you even see I make the note there. If we just go back, a mutator method or a set method is a method that usually takes a parameter and then modifies usually a protected private property to be changed into the value that is passed through the parameter. Now, there's a little more to this than that, right? Accessor mutator methods often have a lot more built-in logic to do things like error checking and stuff like that to ensure that that private property is being given, for example, in the case of a mutator, a proper value that can change it. So for example, like you can see on the screen now, if you were setting someone's age, you wouldn't necessarily allow any possible integer to be passed. Like you wouldn't allow a 1 million as a value because no one is age 1 million, right? So maybe you set limits to the amount that that accessor will allow that age value to be. This is a little more common with accessor mutator methods, is programmers themselves write in logic to do this. So that's sort of the theory behind it. But accessor mutators generally have that idea. So an accessor gets a value and a mutator sets a value. All right, let's move on. Now we're going to back a little bit because AP topic 5.6 is just about the idea of what a method essentially is. So let's go back to Unit 2 of the Computer Science 30S course. What is a method, right? So here you can see some of the AP specifics of what they're talking about in terms of creating a method. But if you go back to how I describe this, I start with the theory of what a good method is, how a method can be used to break up a program, how a method allows you to decompose or, like I said, break down a problem. That's one of the ideas behind why we create methods. It also relates to the idea of programmatic thinking or computational thinking or top-down design type thinking, taking a big problem and breaking it into smaller problems, and then breaking those into smaller problems. As you can see here, as it's covered in that 30S course, that's kind of the idea behind it, is let's break those problems down. Then now we can even divide up programming tasks among multiple programmers. Or we can draw upon existing methods that are written by others. Now, one of the other reasons why I break down methods is you end up finding that when you write a lot of code, you end up repeating yourself. Like this example here, where some piece of code, which is raising a number to a power, is repeated several times. And then you think, well, if I wrote a method here, it would avoid me having to write the same code over and over again. So decomposition is one part of methods. Another is avoiding repeatability in your code. I go further into the theory behind this. You'll see here I use this pseudo example of boiling a pot of water. And when I break that problem down, you see, one, the breakdown of the problem, but also two, you see places where the logic could be repeating itself. Hitting both of those two sort of reasons why we write methods is to avoid both of those sort of things and how methods can solve that problem. In that 30S course, I continue the theoretical before we get into the practical. So I use pseudocode to show how a method can call another method, and that can call itself another method, and how the code is now branching or jumping from place to place. So in other words, methods can call other methods, and that introduces the concept of the word call, decomposing the problem and avoiding repeatability. And then even more ideas like how you can think of a method as a small program running within a larger program. All right, another theoretical example is this idea of doing a day's work. And this is me, my example, right? What does Mr. Walks do? He goes to school, he does his work, he goes home. All right, let's break that down. What does going to work mean? And you can see I have fun with that. I have coffee, I bug the students, and then I do some photocopying. That's what teachers are paid to do. And then I move that further into actual pseudocode, right? How going to work means going to school. How going to work means going to work and then going home. But then I break down work, breaking down work to having coffee and bugging the students and photocopying. Then I break down having coffee, what that essentially means, and how that process could continue. How bigger problems can become smaller problems through decomposition, through the idea of writing a method, right? So now that you have the theory down, and now you can see why methods could be a good idea, then I get into the specifics of the details of how to write it in a programming language like Java. And you will definitely have lots of examples to look back on. If you look through the Computer Science 30S example code, you will see lots of different examples of a method like this one here, makestar, right, and how it's called. And then advancing that to the idea of parameters or method inputs, and how some methods require you to pass information to that method. And then I get into more theory like the idea behind a black box programming, where you've already been using methods and calling methods without writing them, like this, right? Where you just know all I got to do is pass this information to the method and it does something for me, right? Black box programming. I don't need to see the method to know how to use it. Okay? And then I get into some more of the specifics of the terminology, like the difference between a parameter and an argument, and how you can pass all kinds of different things. And yes, this is also incorporated into the examples. So you can find lots of different examples of parameters and data passing all through the 30S course, broken down in much slower and more detailed explanations. As this is a review video, I'm not going to reteach all this content. Feel free to look back in these videos to videos from the 30S course and presentations from the 30S course, which break it down in more detail. Okay, in addition, I talk about some of the pitfalls you could run into, like if you have multiple parameters, make sure that order counts in case you have a simple error like that. That the order in which you call a method and pass the arguments has to match up with the order in which you wrote the method and defined the parameters. Then I move on to the idea of an output from a method, or in other words, what a method could return. So methods that don't return anything and have no outputs are void methods. That's literally what the word void means. It means nothing. However, you can have methods return values, which is when you use the return keyword to send back something from the method. And here you can see an example of that. And there are lots more examples in that 30S example code of, and again, this is a review, of methods that return things like primitive data types like doubles and integers and strings. And if you advance your coding, you eventually learn that you can return more complex data types like class level objects and things like that, or arrays can be returned. But that's a topic for another day, okay? Feel free to look back at parameters, return types, and methods in general in the 30S contents. Whew, so that's a lot for topic 5.6. Topic 5.7 now shifts gears to static variables and methods, and the keyword static and what it means. So the keyword static is covered in detail in the 40S computer science course. Here you see the subtopics of 5.7, okay? So that keyword static is used in Java as it's applied to a variety of things, but let's focus on what we're talking about here. Static properties and static methods. Okay, if you use the modifier word static when declaring something like a data structure, like a static variable, what it means, and here you can see that, public static int total students within a class, is it means, and I'll back up here, that when you declare something as static, it essentially means that property belongs to all of the class, not each individual object. The way I teach it in the 40S courses, you can think of the word static as shared. You're essentially sharing this data structure amongst all the objects. So let me try to explain that with a bit of a diagram here. So here you see a variable like total students is defined as static. So let's say in theory, we use that, and I'll just jump ahead a little bit here, so that we had, say, 4 objects, 4-person objects, Sally, Katie, Peter, and Matt. Each object would have its own individual properties, but the property total students would be shared by all the objects of the class because it belongs to the class. It doesn't belong to the object. Now I'll just back up here a little bit. Okay, you can see that then if I increased it by 1 in the constructor of the student class, it means that all the objects, when they are constructed, would be incrementing the same variable because it's all shared. Now, when you apply it to methods, you can kind of, see that right here. This is a static method, which means the method belongs to the class. What that means is you can call the method, not just from the objects, but you can call the method using the dot or accessor operation from the class itself. So you don't have to create a person object to call the method. You can say person, the name of the class, dot, and then call the method. And chances are you were doing this with things like JOptionPane. JOptionPane dot show message dialog shows you that the show message dialog method is a static method of the JOptionPane class. Plenty of examples of static methods and static properties in the 40S unit called Advanced Classes, and you can access that content quite easily. All right, moving into the latter half here, topic 5.8, scope and access. This is also a bit of a step back because I talk about scope in my 20S computer science course in the 3rd unit when I first introduced the idea of variables. Now, yes, scope is expanded on in the 30S and the 40S course, but in general, scope can be just thought of as where something is accessible, or as I point out here, where it can be thought of as alive, okay? So if we think about variables, the simple way to define scope is local versus global. Is it a local variable? Is it a global variable? So local variables exist within something like a method, right? Now here you can see that. These 2 variables exist within a method. So the scope of those variables is that they are only available within the method itself. The method itself knows what the variables are, can change the variables, can access the variables, but outside of this method, they don't exist, okay? Now, that's not always what you want. Sometimes you want a variable to be accessible in multiple methods, or more importantly, you want it to be alive longer, so it exists for a longer scope. This would be what you would call a global variable. Sometimes in Java, you could call this a class level variable. It's declared at the level of the class, so you declare it right under the class header line, and that means it's available to all the methods know what it is, and it's available and it lives in quotes, it exists as long as the class itself exists. All right, let's move on to topic 5.9. Our second last topic is about the keyword this. So we've already kind of covered this, but let's just go back and take a look at how the keyword this applies. So the keyword this is an explicit reference to the class and the later object of that class itself. So you can see it used, as I did before, in a constructor method to make a difference so we don't have a name conflict between age as a parameter and this.age meaning the property. So this.age says, oh, this class is age, whereas just the word age means, oh, that's the parameter. And that again helps with the idea of scope, right? What is the scope of the variable we're talking about here? You can find these also in things like accessor mutator methods. You can see there it's using this.name so that we don't have a name conflict within the parameter name. Okay, and again, you can find lots of better explanations for this in the 30 and 40S computer science courses. This is a review of that AP content. Our final AP content for this Unit 5 actually is an interesting one because it really isn't applicable to the exam itself, but it's something as a computer science student and as a computer scientist you should always have in the back of your mind: the ethical and social implications of computing systems, or computer science in general. So here you can see some of those subtopics. Well, let's just talk briefly about this. So what we're talking about here is, again, not specifically covered in the AP exam, but we're talking about concerns of computing like data theft or identity theft. We're talking about things like addictions to digital worlds, like internet addictions, digital treadmills, digital citizenship, being a good digital citizen, social ethical considerations of these things in general, cyberbullying, the potential downside of things like artificial intelligence. In general, as a computer science student and sort of a IT student in general, someone who likes technology, these are things that should be part of your consideration in kind of everything you do in the IT or the computer systems world. All right, let's summarize the unit. We're ready to wrap up. We've seen this part of the AP curriculum, how it breaks the content of writing classes down in more detail. We covered the anatomy, the construction, the documentation, the accessor and mutators, how to write methods, static variables and methods, scope and access, the this keyword, and those ethical considerations. We broke down all of those, and I gave you an idea of how that was covered in a lot of the previous coursework that a lot of you have done for me in computer science 20S, 30S, and 40S in general. Now let's look at an exam type question under this umbrella. So here's the question. Public class example, private int x, constructor not shown. It asks, which of the following would be a correct header for a method of the example class that would return the value of that private variable x so that it can be used in a class other than example? So keeping in mind what we just discussed, let's look at our options here. So first of all, if it's going to be used in a class outside of example, the method has to be public. Otherwise, it's an encapsulated method. So the first two, A and B, are right off the table. They can't be private methods. Okay? So now we're down to 3. If it is, and it kind of hints at it, we are accessing a private property, it's going to be a get method. All 3 of those fit that description. But if we're actually getting the value of x, we should be returning that value. D and E are both void methods. They don't return anything, which leaves C as the best possible answer on the table here. And you can see I broke that down right there. But that should be a pretty easy AP question to quickly break down which is the correct answer they're looking for there. All right. Before we move on, let's just take a look at, and the links will be available in the description of this video. This is my website where you can find a lot of the links to this content. But let's quickly also, you can find, for example, a lot of coding examples all through there. But let's just quickly just jump through these learning objectives and vocabulary. From those learning objectives, and I'm not going to read them all, I pulled out a bunch of vocabulary words. You want to make sure that your knowledge of this content matches that vocabulary. Because the last thing you want is the AP asks you a test question and you get stumbling over the word. Like, for example, the word, I'm just pulling one out there, behaviors, right? So if all of a sudden in the AP exam it uses the word behaviors, you're like, what is that? What is behaviors? Because in my course, maybe I didn't use that word specifically. I used methods, or I used functions, or I used actions, right, as it applies to classes. Once you have a general idea that, oh, they're all talking about the same thing, then the question doesn't stumble you anymore. You're right on to just breaking down the question itself. Or the word encapsulate, right? Did you really, and how is that related? So let's just quickly just wrap up this video by me again showing you, and you can I'm not going to read all this to you, but you can go through this and pause this if you want. A quick cheat sheet summary of what is a class, what are properties, what are methods. A quick sort of what are methods? Why do we use methods? How are they analogous to things like functions in math or little machines, right? Just a quick breakdown of that, okay? How do I write a method? Let's break down some of the sort of basics of that. What are parameters? What do I mean by passing? So again, feel free to pause this video or dive into some of my resources to access this if you're still really confused about some of the basics of this content. What does returning a method mean? What's a void method? Okay. What does commenting a method look like? What does that specifically look like? What does overloading a method mean? Okay. What is some of the thinking or the methodology behind creating the philosophy of why we create methods? What is a constructor method as it applies to classes? What is that specifics? What is the this keyword specifically used within methods itself for? What is that concept of encapsulation versus private versus public? How does that all tie together? What does override versus overload mean? What does that mean in this context? What does that keyword static, that modifier keyword really mean? And what is the analogy I can draw from it? What is the object class in Java? And that will really kind of help you break down some of that vocabulary and some of those main points. All right, everybody, that's my summary video for this part of the AP curriculum. Like and follow, and please use the resources below or contact me if you have any questions. Have a great day, everybody.